We'll see the duality problem. Okay, before we start solving the problem, I'll just show you one example of how what is the actual changes that happen and how you make the changes. Okay, so this is an example. Okay, here we have the primal. So the initial LPP that you take will be called as a primal, and the other one, the opposite one, will be called as the dual. Okay, over here we have the maximization, right? Here we have the maximization. So correspondingly in the dual you will have a minimization problem. Okay, here I have Z. I'll write it over here as Z dash. Okay, the number of constraints in the primal will be the number of variables that will be there in the dual. Okay, here how many constraints do you have? 1, 2, 3. Okay, so you will be having 3 variables in the dual. What are they? Y1, Y2, and Y3. Okay, or you can name it as W1, W2, and W3. There is no problem. Okay, then over here you have two variables here, no? X1 and X2 are the two variables in the primal. They are telling us X1, it is greater than 0. Okay, all the values of X1 should be greater than 0. But in the case of X2, they are telling X2 has no sign restriction. Okay, if such a constraint is there in the primal, then what will be the corresponding one in the dual? In the dual, it will be a equal to sign. Okay, so the this is the second variable here in the primal. No, X2 is the second variable. So the corresponding second constraint will have an equal to. Is it clear? Similarly, over here, the third constraint is having the sign equal to. Okay, so the third variable in the dual will have no sign restriction on Y3. Okay, this is how it will be formed. Okay, then if it is less than or equal to in the primal, then in the dual it will be greater than or equal to. Vice versa. If it is greater than or equal to in the primal, then it will be lesser than or equal to in the dual. Okay. So this concept I'll just explain once more. Here the third constraint is having an equal to. Okay. So in the dual, the corresponding third variable, which is the third variable, y3. Y3 will have no sign restriction. Okay. Similarly, over here in the primal, they are telling the second variable, that is x2, has no sign restriction. So vice versa, in the dual, what will happen? The second constraint will have an equal to symbol. Okay, hope it is clear now. We'll solve a problem and then I think we will be able to solve it better. Okay. Okay. So here we have this LPP. Okay. So initially what you have to do is you have to convert it into a canonical form. Okay. Canonical form means if you have the maximization LPP, then all the constraints should be of less than or equal to type. Okay. If the LPP is of minimization, then all the constraints should be of greater than or equal to type. Okay. So that is the canonical form. That is called as the canonical form. So initially when before. Okay, and one more thing over here we have to take care is here they are telling y is unrestricted. Okay, y is unrestricted, then we have to write y is equal to y dash minus y double dash. Okay, so we'll solve it. Solution. Over here, first of all, you have to check for y. Okay, y they are telling it is unrestricted. So just change y is equal to y dash minus y double dash first of all. Okay, so here I'm changing it as since the variable y is unrestricted, it can be expressed as y is equal to y dash minus y double dash. Okay, where y dash comma y double dash is greater than or equal to 0. Okay, because we have such a constraint, you have to replace y with y dash minus y double dash. Okay. So on formulating the LPP we have, so LPP becomes, okay, so in before changing it into canonical form, you have to replace y with y dash minus y double dash. Okay, so the LPP becomes maximize z is equal to x plus 2 into what we have over here, y dash minus y double dash. So 2 into y dash minus y double dash. Okay, subject to what are the constraints? 2x plus 3. Instead of y, I am writing y dash minus y double dash. Okay, greater than or equal to 4. Then the second constraint becomes 3x plus 4 into y dash minus y double dash. Here it is equal to 5. So I am putting it as equal to 5. Okay, and x comma y dash comma y double dash are all greater than or equal to 0. Okay, after that what happens? You have to convert it into the canonical form. Okay, so convert LPP to canonical form. Okay, and simultaneously I'm going to take the 2 inside. Okay, similarly 3 inside, 4 inside. I'm going to open this brackets. Okay, so I have maximize z is equal to x plus 2 y dash minus 2 y double dash. Okay, I'm taking this 2 inside, so I'll get it this way. Subject to, see, this is maximization problem now. So all the constraints should be of less than or equal to 10. So I'm going to open this bracket as well as I'm going to multiply this entire constraint with -1 so that I can reverse this symbol. Okay, maximization. Here it should be less than or equal to. Okay, so subject to minus 2x minus 3y dash minus into minus, it will become plus. So plus 3y double dash, the sign will reverse less than or equal to -4. Okay, then again over here we have an equal to. So when we have an equal to, what do? We have to convert it into a canonical form. So all the symbols should be of less than or equal to 10. We have to replace this equal to. Okay, so what do? We write the constraint, okay, and then we put greater than or equal to as well as less than or equal to. Okay, only then we can replace this equal to. So I'll take down this constraint there. 3x plus 4y dash minus, I'm opening this bracket, minus 4y double dash, I'm writing it as greater than or equal to 5. Okay, and this constraint I have to change it, no? Okay, first of all I've written greater than or equal to. Similarly, I'm going to write less than or equal to also. Okay, so it becomes 3x plus 4y dash minus 4y double dash. Okay, for replacing this equal to, first of all I've written greater than or equal to. Okay, so take the same constraint again and put less than or equal to 5. Okay, is it clear? Same constraint. So this equation becomes converted into 2 over here. Okay, for replacing the equal to sign. Okay, equal to sign replaced by greater than or equal to and less than or equal to. Okay, now again you see over here this is maximization problem. So we need to convert this greater than or equal to into less than or equal to type. Okay, so for that what do? Yeah. Okay, so for that you have to multiply on both sides with -1. Okay, so this equation alone I'm going to take over here. Okay, so minus 3x plus, here we have instead of plus we have minus 4y dash, minus into minus it will become plus. Okay, 4y double dash less than or equal to, this greater than or equal to sign will change into less than or equal to, on the other side also I'm multiplying with -1, so I have 5. Okay, so this is the canonical form. What are the constraints? This is the first constraint. Okay, this is the second constraint and this is the third constraint. Okay, I'll just write it 1. This is the second constraint and this is the third constraint. So we have converted this into the canonical form. Next, what do? We have to take the body of this matrix. Okay, so I'll take the body of the matrix. Body of primal. This is our primal problem. No? First LPP that we initially take is called as the primal. Okay, so body of the primal A. So what are the constraints here? The coefficients. Here it is -2. Here -3, 3. Okay. -2, -3, and 3. Next, we have 3. This constraint has been changed into this one. So I'll take this constraint. Okay. So -3 here, -4 here, 4. Next one, this constraint. Okay. 3, 4, -4. Okay. So these are our 3 constraints. I'm going to take the transpose. Okay. Transpose of primal, that is represented as A on top T. Okay. So how will it become transpose? How do we take transpose? -2, -3, 3 on the horizontal. We'll write it as vertical. Okay. -2, -3, 3. Again, -3, -4, 4. -3, -4, 4. 3, 4, -4. 3, 4, and -4. Okay. So this is how we get it. Just give me a second. Okay. Yeah. Now after that, what we do is we have to take the number of constraints. Number of constraints in primal. How many constraints do we have? We have 3 constraints: first, second, and third. Okay. Number of constraints in primal is equal to 3. So number of constraints in primal is equal to 3. So number of variables in dual will also be 3. Okay. Namely, okay, let us name it as W1, comma. See, the second constraint over here. The second constraint over here is what we split into 2, right? Okay, this because of this equal to, we got 2 constraints from this single constraint. Okay, so instead of the second variable, we will write as W1 dash, and third variable we'll write it as W2 double dash. Okay, because the second constraint itself we have written as 2 constraints. So we will not write it as W2 and W3. Okay, did you get it? Okay, so here I have W1, comma, because the second constraint in the LPP, our initial LPP, second constraint we got from that second constraint, we got 2 constraints, right? Because of that equal to sign, we got 2 constraints from the single one because we need to convert it into canonical form. Okay, so in the dual, we will not write it as W2 and W3. We will not write it like that. Instead of that, we will write W2 dash, comma, W2 double dash. Okay, where W1, comma, W2 dash, comma, W2 double dash is of greater than or equal to 0. Okay, now we have all the things for writing the dual. So I'll write the dual now. Okay, so the dual LPP becomes, okay, initially our dual LPP was of maximization type. So my primal was maximization. So my dual will be a minimization type. Minimize z dash is equal to, here, see, the right hand side of the constraints will become the coefficient of the objective function in the dual. Okay, so right hand side of the constraints is, we have three constraints here now. First one, it is -4. Second constraint we have right hand side as -5, and for the third constraint we have 5. Okay, so -4, -5, and 5 will be the coefficients of the objective function in the dual. Okay, so here I have -4, okay, -5, and 5. Okay, what are the variables? W1, W2 dash, okay, and W2 double dash. Okay, so clear. Now subject to, what are the constraints? Here we have formed the transpose matrix, no? So these are going to be the coefficients in the dual. Okay, so just take it down. -2, -3, 3. Okay. -3, -4, 4, 3, 4, and -4. Okay. Now fill it with the variables W1, W1, W2 double dash. Can you see that? This is the coefficient matrix that I've taken from the transpose. Okay. And then I'm filling it with the variables. Okay, plus W2 double dash. Okay. So here it is W1. Here it is W2 dash plus W2 double dash. Similarly, W1 plus W2 dash minus W2 double dash. Okay, here we have minimization problem. So all the variables, all the constraints are going to be of greater than or equal to 10. Okay. Now, what are going to be the right hand side of the constraints? It is the, well, it will be what? It will be the right hand side of the constraints are going to be the coefficients in the objective function. Okay, coefficients in the objective function is 1, 2, and -2. Okay. Okay. What is our objective function? See over here, we converted it, no? We had our objective function in the primal LPP as x plus 2y. Instead of y, we replaced it with y minus y dash minus y double dash. Okay, y dash minus y double dash. So we opened the bracket, we got our final objective function as this one. What are the coefficients here? 1, 2, and -2. Okay, so this 1, 2, and -2 are going to be the right hand side of the constraints in the dual. Okay, so 1, 2, and -2. So over here I have 1, 2, and -2. Okay, clear? Now what I'm going to do is I'm going to take this W2 and W2 double dash into one bracket. Okay, so how do I do that? That is the LPP becomes, the dual LPP becomes, okay, minimization Z dash is equal to -4 W1 minus of, I'm going to take this 5 outside, I'm going to take W2 dash and W2 double dash into one single bracket. Okay, so I took minus outside, I am taking one 5 outside. Okay, so minus 5 W2 dash, I want to get that. So I will write W2 dash. So if I open the bracket, what will it become? Minus 5 W2 dash. Similarly here, minus 5 W2 dash. Okay, next one, I have to get 5 2 double dash. For that I will write minus 5 2 5 W2 double dash. Okay, if I open the bracket, what will I get? Minus of 5 into minus. So it will become, or here you don't have to write 5. Minus 5 into minus W2 double dash. What is that? Minus into minus, it will become plus. So 5 W2 double dash. That is what you have, 5 W2 double dash. Okay, is it clear? I'm just taking minus 5 outside. Okay, so that I will get these two variables in a single bracket. Okay. Now, subject 2. Again, over here also I'm going to do the same thing. W2 and W2 double dash, I wanted to bring it into the same single bracket. Okay. For that, -2 W1 -3. -3 I have taken outside. So what will I have inside? W2 dash minus W2 double dash. Okay. Then again, the constraint over here greater than or equal to 1. Okay. Similarly, -3 W1 -4 I'm taking outside, W2 dash minus of W2 double dash greater than or equal to 2. The third constraint, 3 W1 plus 4 I'm taking outside, W2 dash minus 4 W2 double dash, okay, greater than or equal to -2. Okay, that much is clear, right? Now, what I'm going to do is I'm going to replace W2 dash minus.
Ma'am, third constraint only 4.
Yeah. Okay. So over here we have W2 dash minus W2 double dash. Instead of that, I'm going to replace it with W2. Okay. Let W is equal to W2 dash minus W2 double dash. Okay. And why do I do that? So that the dual variable W2 is unrestricted in sign. Okay, why do we bring it under one bracket? Because in the question it is told now. What is it told in the question? Okay. See over here we have, see over here the second constraint over here we have equal to. Okay. So in the dual, what is the variable that is corresponding to the second constraint? It is W2. So in the primal, if we have equal to, in the dual, we should have unrestricted sign. Okay, in the dual, what is the variable corresponding to the second constraint? It is W2. So for that, we are doing all the steps. Okay, clear? Okay, so we have this way. Okay. Okay. So my LPP, I'm going to replace this term by W2. So how will it become? The LPP becomes minimize Z dash is equal to, see over here, minus W1 minus 4W1 minus 5W2. Okay. See this one. Instead of this, I'm replacing it to W2. Again, subject to minus 2W1 minus 3 instead of this W2 greater than or equal to 1. Similarly, minus 3W1 minus 4W2 greater than or equal to 2. 3W1 plus 4W2 greater than or equal to minus 2. Okay. And what will we have? W1 is greater than 0. W2, we have unrestricted sign. Okay. W2 is unrestricted in sign. Okay. So once you replace W2 dash minus W2 double dash, okay, as W2. So from that time onwards, you can write it as W2 is unrestricted in sign. Okay, whereas W1, it is going to be greater than or equal to. Okay, clear? Now what we can do is, see over here, in our question, see, here, see, y is unrestricted. It is given as y is unrestricted. So in the primal, if y is unrestricted, then in the dual, what will happen? Instead of y is the second variable. So in the dual, the second constraint is going to be of the sign equal to. Okay, is it clear? Okay, whatever happens in the dual, the opposite is going to happen in the primal. Okay, so over here I have y is unrestricted. Y is the second variable. Okay, so in the dual, what will happen? The second constraint is going to have equal to sign. Okay, for that, what I'll do is, see over here I have, just check the symbols over here. Compare these two constraints, minus 3W1 minus 4W2 greater than or equal to 2 and 3W1 plus 4W2 greater than or equal to minus 2. Okay, if I multiply this second constraint with the minus 1, then I will get the third constraint, but with the opposite inequalities. Okay, just see what I'm going to do. Again, the LPP becomes, okay, minimize Z dash is equal to minus 4W1 minus 5W2. Okay, subject to first constraint, I'm writing it like that itself, minus 2W1 minus 3W2 greater or equal to 1. Okay, the second constraint over here, I'm going to multiply it with minus 1. Okay, on both sides. So 3W1 plus 4W2. When I multiply, the inequality will reverse. Less than or equal to 2. Similarly, the third constraint, I'm just writing it like that itself. Plus 4W2 greater than or equal to minus 2. Okay. On both sides for the constraint 2. Okay. for constraint 2. Okay, now just see over here, 3W1 plus 4W2 less than or equal to 2. 3W1 plus 4W2 greater than or equal to, over here. Okay. Okay, when I multiply with -1 on both sides, I will have, see this equation, this constraint I'm multiplying on with -1, I will have -2 over here. No, on both sides I have to multiply with -2. Okay, so just compare these two constraints. 3W1 plus 4W2 less than or equal to -2. Say again, 3W1 plus 4W2 greater than or equal to -2. Okay, the constraints remain the same. Only thing is the inequalities are of opposite signs. Okay, so what you can do is, initially did you see when we had equal to in the primal LPP, what did we do? We replaced it with greater than or equal to and less than or equal to. Okay, similarly over here we are having greater than or equal to, okay, less than or equal to and greater than or equal to. So instead of having two constraints here, we can just replace these two constraints with a single constraint having an equal to. Okay, is it clear? So again the LPP becomes minimization z dash is equal to -4. There is no change for the objective function. Subject to first constraint also remains the same, greater than or equal to 1. The second constraint and the third constraint, I'm just joining it into 1. Okay, so it becomes 3W1 plus 4W2. Instead of less than or equal to and greater than or equal to, I can convert it into a single equal to sign, equal to -2. Okay, and W1 is greater than or equal to 0. W2 we already got here now. W2 is unrestricted in sign. Unrestricted in sign. Okay, unrestricted in sign. Okay, so this is how we convert it into a dual problem. Okay, so just see, I'll just compare the question and show you over here. This is our objective function. Over here y is it is unrestricted. Okay, so y is unrestricted, so we have this is the second variable y. So we have two variables in this question, no, x and y. So y is the second variable. So now in the question they are telling y is unrestricted. So this is second variable, so the corresponding constraint, second constraint in the dual should have equal to sign. Correct, no? So in the answer also we got it that way. This is our second constraint in the dual. In the second constraint we are having a equal to sign. Okay, now over here the second constraint is having an equal to sign. Okay, second constraint has an equal to sign. What is the second variable in the dual? Second variable is W2. So here if it is equal to, W2 should have unrestricted sign. Okay, so in our dual we have got W2 is having unrestricted in sign. Okay, and all the others will become the opposite. Okay, dual in the primal, what you have, the opposite will be in the dual. Okay, so this is how we solve a problem, and we'll quickly solve one more problem. Okay, so that the same type we'll solve one more problem. Okay. This is having this is a little more complicated, so you will have to answer me when I ask for the answers. Okay. So initially, what happens over here? Just check. They are telling x3 is unrestricted. So immediately, what you will do? You have to replace x3 with x3 dash minus x3 double dash. Okay. So just replace it with solution. Okay. Replace, this is going to be a primal. Okay, replace the primal LPP with x equal to x3 dash minus x3 is equal to x3 dash minus x3 double dash. Okay, so our LPP becomes LPP becomes minimization z is equal to 4x1 plus 5x2 minus 3. Instead of x3, x3 dash minus x3 double dash. Okay. Similarly, subject to, okay, first of all, let us replace all x3 with x3 double dash. x1 plus x2 plus x3, we are replacing it with x3 dash minus x3 double dash is equal to 22. Similarly, 3x1 plus 5x2 minus 2, x3 dash minus x3 double dash less than or equal to 65. Okay, x1 plus 7x2 plus 4x3 dash minus x3 double dash greater than or equal to 120. Okay, where x1 comma x2 comma x3 dash comma x3 double dash is all greater than 0. Do you see? Okay, I've just replaced x3 with x3 double dash. Now what I'm going to do is I'm going to open the bracket as well as, see over here you have some things that you have to convert it into the canonical form. Okay, so converting to canonical form, here we have minimization. So all the constraints should be of greater than or equal to type. Okay, so minimize z is equal to 4x1 plus 5x2 minus, I'm going to open the bracket 3, x3 dash minus into minus will become plus. Okay, plus 3x3 double dash. Subject to, here you have equal to. So this equal to you have to replace it with less than or equal to and greater than or equal to. Okay, so x1 plus x2 plus, okay, x3 dash minus x3 double dash greater than or equal to 22. And again you have x1 plus x2 plus x3 dash minus x3 double dash less than or equal to 22. Okay, did you see? I'm replacing the first constraint over here. It is equal to. So the same constraint I'm taking it down and replacing it with greater than or equal to and less than or equal to. Okay. Here itself I'm going to see over here we have a minimization problem now. So this should be of greater than or equal to type. How can I make it greater than or equal to? Multiply both sides with -1. Okay. So just this constraint multiply by -1. So what will you have? Minus x1 minus x2 minus x3 dash plus x3 double dash greater than or equal to -22. Okay, so that is the first constraint. Now we are checking the second constraint. It is less than or equal to type. Our question is minimization, so we have to change it into greater than or equal to. Multiply on both sides with -1. Okay, so it will become minus 3x1 minus 5x2 plus, can you see here, minus 3x1 minus 5x2, this minus will become plus. Okay, so it is plus 2x3 dash and this minus into minus into minus is plus. Okay, again you have one minus that you have to use for converting this into greater than or equal to. So we have three minus and one more minus. So it is again, in effect, it is a minus. Okay, so minus 2x3 double dash. Minus 2x3 double dash. Our symbol is greater than or equal to. On the other side, we have 65. Okay. Okay. Here we have multiply by -1. So that is how we got the third constraint. Okay. Now we have one more constraint here. This one is already of the form greater than or equal to, so we don't have to make any changes. Just write it down. x1 plus 7x2 plus 4x3 dash minus 4x3 double dash greater than or equal to 120. Okay. Now we have x1 comma x2 comma x3 dash comma x3 double dash all are greater than or equal to 0. Okay, after getting so much, what are the constraints that we're taking? This is the first constraint. Okay, this is our second constraint. This is our third constraint, and this is our fourth constraint. Okay, get the matrix of the coefficients. Okay, so body matrix of primal A is equal to, what are the body matrix? Here you have 1, 1, 1, minus 1. Okay, 1, 1, 1, minus 1. Okay, second constraint, minus 1, minus 1, minus 1, 1. Minus 1, minus 1, minus 1, 1. Third constraint, minus 3, minus 5, 2, minus 2. Minus 3, minus 5, 2, and minus 2. Last, 1, 7, 4, minus 3. 1, 7, 4, 1, 7, 4, minus 4. Okay, so this is our body matrix of the primal. Now you have to take the transpose of it. 1, 1, 1, minus 1. Okay, it will become, just give me a second. Okay, so here I have 1, 1, 1, and minus 1. Okay, so it is 1, 1, 1. The transpose of this 1, 1, 1, and minus 1 transpose. I have 1, 1, 1, minus 1. Minus 1, minus 1, minus 1, 1. Minus 1, minus 1, minus 1, 1. Here minus 3, minus 5, 2, and minus 2. Here 1, 7, 4, and minus 4. Okay, this is our body matrix. Okay, how many constraints do we have in the primal? We have 4 constraints. So we'll have 4 variables in the dual. Okay, number of, you can see number of constraints in primal is equal to number of variables in dual. Okay, and we have to name them. Namely, over here, just remember one more time over here, the first constraint was an equal to. So this constraint alone gave us 2 constraints. So I will not name it as W1 and W2. Instead of that, I will name it as W1 dash and W1 double dash. Okay, so the first 2 constraints will be W1 dash and W2. Sorry, W1 dash and W1 double dash. Okay, so here namely W1 dash comma W1 double dash comma W2 and W3. Okay, now you write the objective function. Our main question, it was minimization Z. So in our dual, it will be maximization Z dash. Okay, maximization Z dash is equal to the coefficients of the objective function will be the right hand side of the primal. Okay, constraints of the primal. Okay, what are the right hand side of the constraints of the primal? Here we have 4 constraints. What are the right hand side? 22, minus 22, minus 65, and 120. Okay. So here we have first constraint, it is 22. Second constraint, minus 22. Third constraint, minus 65. Fourth constraint, it is 120. Okay. Here you have to keep these variables in the same order in this one. So it will become W1 dash, W1 double dash, W2 plus here we have W3. Okay, subject to constraints. Okay, this is the body matrix of the dual. Okay, so here we have 1, -1, -3, 1. Okay, it is W1 dash, W1 double dash, W2 plus W3. Okay, now what is going to be the right hand side of the dual? Over here I have maximization, so my symbol is going to be less than or equal to. Okay, we'll just complete it and then we'll come back. Okay, over here the second row I have 1, -1, -5 and 7. 1, -1, -5, 7. Third row 1, -1, 2, 4. Fourth row -1, 1, -2 and -4. Replace it with the variables W1 dash, here also W1 double dash, W2, W3, W1 dash, W1 double dash, okay, W2 plus here W3. Okay, this is 4. W1 dash plus W1 double dash, W2 and W3. Okay, our symbol is going to be less than or equal to, because over here we have maximization problem. Okay, less than or equal to, less than or equal to. Right hand side will be the coefficients in the objective function of the primal. Okay, primal is this question. Okay, over here the coefficients are 4, 5, -3, 3. Okay, so I'm writing 4, 5, -3, 3. Okay, wherein W1 dash, comma, W1 double dash, comma, W2, comma, W3 all are greater than or equal to 0. Okay, now what we should do? Like the previous problem, here we have W1 dash and W1 double dash. Okay, we have to make it into a single variable, that is W1, only then we can put it as W1 unrestricted inside. So what we should do is we have to make it into a common bracket. Okay, so the LPP becomes here maximize Z dash is equal to, I'm going to take 22 outside, W1 dash minus W1 double dash, okay, minus 65 W2 plus 120 W3. Okay, the constraints subject to, here again I'm taking W1 and W1 dash into a single bracket. Okay, so W1 dash minus W1 double dash minus 3 W2 plus W3 less than or equal to 4. Similarly, W1 dash minus W1 double dash, okay, minus 5 W2 plus 7 W3 less than or equal to 5. Okay, W1 dash minus W1 double dash plus 2 W2 plus 4 W3 less than or equal to minus 3. The last constraint, I'm taking minus outside, W1 dash. Okay, I have to get plus. Okay, so for that, already over here, I have a, I'm taking minus outside over here. Okay, so minus outside W1 dash. Okay, I should get plus here. So what will I do? I will multiply over here with the minus. So minus into minus will become plus. Okay, minus 2W2 minus 4W3 less than or equal to 3. Okay, now what will I do next? Next step, I'll replace W dash minus W2 double dash with W1. Okay. So the LPP again becomes, okay, replace W1 is equal to W1 dash minus W1 double dash, because the dual variable W1 is unrestricted. Okay, unrestricted. Now the LPP becomes maximize Z dash is equal to 22 W1. Okay, instead of this, I can write W1. 22 W1 minus 65 W2 plus 120 W3. Okay, the LPP reduces to smaller one. Subject to again W1 minus first constraint 3 W2 plus W3 less than or equal to 4. Similarly, W1 minus 5 W2 plus 7 W3 less than or equal to 5. Again, W1 plus 2 W2 plus 4 W3 less than or equal to minus 3. Again, minus of W1. Okay, can you see? Okay, minus of, here I am replacing it with W1. Okay, then minus 2W2 minus 4W3 less than or equal to 3. Okay, where W1 is, see, we have converted it into W1, a single variable instead of W dash and W2 double dash. So W1 is unrestricted in sign and W2 comma W3 is greater than or equal to 0. Okay, now what do we do? Okay, now we have to check over here. We had see this equal to in the LPP that corresponded to the first variable in the dual. First variable is W1. We have converted that into unrestricted. Okay, so equal to will become unrestricted in the dual. Okay, now what they're telling, X3 is unrestricted. Okay, X3 corresponds to, this is the third constraint. So the third, this is the third variable. So the third constraint in the dual should become equal to. Okay, it is all opposite. Here, if it is unrestricted for X3, okay, X3 is the third variable. So corresponding third constraint in the dual is going to be equal to. Okay, so just check the LPP here. Can you just compare these three, the last constraints here, these two constraints, if you just multiply any of these constraints with -1, you will get the opposite constraint. Okay, but the only difference is it will be opposite sign. Okay, if it is opposite sign, you can replace it with equal to. Okay, so now what I'm going to do is I'm going to, the LPP becomes, okay, I'm going to, okay, and just take it as a equation number, it will be 5, I guess, no? So 5, this is the fifth constraint. Fifth constraint, I'm going to multiply it with -1. Okay, so LPP becomes, again, same maximization, Z dash is equal to, okay, Z dash is going to remain the same. So 22 W1 minus 65 W2 plus 120 W3 subject to, first constraint will remain the same, W1 minus 3 W2 plus W3 less than or equal to 4. Can you see? The second constraint also will remain the same, W1 minus 5 W2 plus 7 W3 less than or equal to 5. Okay. The third and the fourth constraint, I'm going to join it into one constraint. Why? Because in the question, it was told X3 is unrestricted. X3 is the third variable. So the corresponding third constraint in the dual is going to be equal to. Okay, here you have unrestricted. So in the dual you will have equal to. Okay, equal to for which one? The third constraint, because here the third variable is unrestricted. Hope you got it clear now. Okay. So over here I'm going to multiply the third constraint with the -1. So I have minus W1 minus 2W2 minus 4W3. The sign will reverse. It is greater than or equal to -3 into -1. It will become 3. Okay. So did you see, this is the constraint wherein I have multiplied with -1 on both sides for the third constraint. Now the fourth constraint will remain the same. Just take it down. Minus W1 minus 2 W2 minus 4 W3 here. Okay, less than or equal to 3. Okay, so compare the two constraints. Compare the two constraints here. It is all the same, just for the symbol. Okay, symbol is greater than or equal to and less than or equal to. Just replace these two with an equal to symbol. Okay, replace with equal to symbol. Again, the LPP becomes, okay, maximization. Objective function is going to remain the same. Maximization Z dash is equal to 22 W2 dash minus 65 W2 plus 120 W3 and subject to W1 minus 3 W2 plus W3 less than or equal to 4. The second constraint W1 minus W2 plus 7W3 is less than or equal to 5. Okay. Instead of third and fourth constraint, I'm writing it as minus W1 minus 2W2 minus 4W3 is equal to 3. Okay. Wherein W1 is unrestricted. Unrestricted in sign, and W2 comma W3 is greater than or equal to 0. Okay, clear now? So this is the way that we will write the dual of a primal LPP. Okay, so for exam, they might ask you write the dual of the primal LPP. So this is how you will have to write the dual. Okay.